Hello everyone. In this whole video, we will discuss on fragment offset of IP header. And we have covered more information about IP header, that is flags, identification, which is colleagues of fragment offset. Because if you do not have information about identification and about flags, then you will not understand about fragment offset. So first, if you want to learn it, then please watch my previous videos related from flags and identification, and in previous video you can learn every remaining term we have discussed. That means version, internet, header length, type of services, total length. Now let's start with fragment offset for a better understanding. Here, this field is 13-bit field. This field is 13-bit field. Now, why we use this field? Because we want to reassemble the fragment. Clear? We want reassemble the data which I received. Clear? So this field is used as a indication. That means this gives the if this field is used, then on the basis of this field we can decide there is sequencing. And if you understand, if you have information about central tendency, that in central tendency you can say cumulative frequency, such type, you have received 5, then you receive 10, then 15, then 20. That means you are increasing. This 10 gives the information of previous. This 15 gives information of previous. This 20 gives information of previous. Such type. You should understand about this. Clear? That means if you have information about cumulative frequency, that means CF, that means in the same manner we can say that this is fragment offset. Clear? So it is used for sequencing data, sequencing of data according data size. Sequencing of data according data size. Clear? This is the definition. That means this is the statement for fragment offset. So this information is used to reassemble the data. To reassemble the data for all fragments. Clear? Now, for a better understanding, we should prefer some pictorial understanding. Here, this is a sender side router and this is a receiver side router. Clear? Now, if MTU for this field is 500, 1500, clear? MTU for this is 500. Then, on the basis of MTU, we can say that generally we can divide in three packets, three fragment. Clear? So here we will make fragment. Clear? Now this is a first fragment, this is a second, this is a third. Clear? Now because this is a first fragment, as a understanding of CF, we can say that fragment offset field set as 0 because it is set by data size. Now then as a starting we can use fragment offset for this is 0. Now suppose this is a 500 bits size of this fragment. Now because we have given 500 bits, then next this fragment fragment offset will be 500 because this information of this second this is the second fragment. That means we have provided this fragment offset 500 means we have provided 500 data before this. If you are looking this fragment that and here if fragment offset is 500, that means it is the indication of previous. That means we have given 500 bytes. Now for this it will be 1000. That means if size of this is 500, that means we have given 500, that means we have given 1000 bytes previous. Clear? This is the understanding about fragment option and why we are saying, why we are emphasizing this is a like as a CF. This first is not matching because randomly if their first number is taken as clear, but here first number taken as a 0 fragment offset, and by with the help of fragment offset 0, then you can say that if there is any packet, any fragment which has FO 0 fragment offset 0, you can say that this is the first packet, this is the first. Clear? This is the best information. Now on the basis of this is a fragment offset line, this line is known as fragment offset. Here we will write clear. Now for more fragment MF, here we will write more fragment. What do you understand about this? That means this is a first, that means if this is a first, then MF will be 1. MF, that means more fragment, it is a on bit. Here we are using on, that means this more fragment is taken as a statement. That means availability of any other type of fragments. That means don't worry, I have more. Don't worry, if MF set as a 1, don't worry, I have more. Clear? That here again MF as a 1, set 1. That means don't worry, I have more. Please move on. Here MF as a 0. Don't go anywhere. I am last. In MF equal to 0 says don't go anywhere. This packet, so don't go anywhere. I am the last. Now MF equal to 0 is the indication of, directly indication of this is a last fragment. This is a last packet. And fragment offset set to 0. This is a first packet. That means by default you can arrange this on the basis of fragment offset 0 and more fragment set to 0. This is information of last packet. This is information of first packet. On the basis of first and last, you can find out the remaining packet. Clear? This is the information. Very interesting point here we are using. Now, as for your kind information, generally we use identification as well, because this is belonging for same packet, so identification should be the same. Clear? Identification should be same. Here we will write, suppose 0x0037, 0x0037, 0x0037. This is the same. Clear? Now, one more information we will tell you. If there is 500, that means 20 for IP header, 20 for IP header. So we can say that data size of this field, what will be? Here, this will be 480 for data size. Not we are using header size, because 20 is a fixed, is a minimum size we have taken, because each packet has its own information header as well. Then after header and data size calculated as the same, then we are deciding MDU. Clear? So data size will be 480 and 480 is used, so we can say that here it is 480 and 20 is also used. We are using the same 480. Clear? Here fragment offset is for a depth understanding. We are here we have provided just an overview and just as a concept. If you try to understand, this will be the same as whatever we say, but it is not same. If on the basis of Wireshark tool, you can understand about this field if you have a depth understanding. Clear? So here we are providing a data size, and it is just usage of fragment offset. Generally you can say on the basis of this data size you decide the fragment offset, not as a 0, 500, 1000, something a difference. Clear? Now suppose you have a given 960, here 448 to the 96, so 9 you have provided, and suppose you have provided 99, then and you have given 1000, so 40 will be remaining. Suppose that 40 will be remaining, so this is a 40. If you send 1000 bytes, clear, then on the basis of this 1000 bytes we are calculating this field. I think you are understanding about this field, and so we will never confuse in uh, this is a now we will meet you within next approach and time to leave protocol and header checksum as well. Then we will discuss source address and destination address, which is very important to for better understanding, and maybe this class will be very longest class. So thank you guys for your dedication and support. Thank you.